So finally, we're at our summary and review. So the three major topics we're going to cover. The first one is rearranging formulas. So for example 1, rearrange the formula v equals 4 pi r cubed divided by 3 to isolate for r. So using our inverse operations strategy, remember we're isolating for r. First we look at what is happening to r. So the first thing we're doing is we're cubing r. Then we're multiplying by 4 pi, and then we are dividing by 3. And that'll give us our volume. So if we wish to undo all these operations, first we need to multiply by 3, then divide by 4 pi, and finally take the cube root of whatever we have. So again, we're going to rearrange the formula v equals 4 pi r cubed divided by 3. And notice we can go right to the answer, because if we look at our inverse operations, it says take v, times it by 3, divide it by 4 pi, and take the cube root of that answer. So if we wish to show our work that happens in between, it says times 3, so this is 3v equals 4 pi r cubed. Divide both sides by 4 pi, so we get 3v over 4 pi is equal to r cubed, and finally take the cube root of both sides. The second major topic we covered in this unit was exponents. So first are our definitions. If we have positive integer exponents, recall that if we have 4 cubed, that's just 4 times 4 times 4. So next is our zero exponent. And any base of the exponent 0 equals 1. And finally, we have our negative integer exponents. And what we know from there is, if we want to make it a positive integer, we take the reciprocal of the base. So the reciprocal 4 is 1 over 4. And it changes it to a positive exponent. So it becomes 1 over 4 cubed, which equals 1 over 64. Next were the laws of exponents. So we have our multiplication rule. If we multiply powers with the same base, we keep the base and add the exponents. For our division law, if we divide powers of the same base, we keep the base and subtract the exponents. And our power of a power law. If we have a power raised to an exponent, then we just multiply the two exponents. And the last major topic was solving exponential equations. And we have two methods for that. One method is to find a common base. So for this example, we have 2 raised to the exponent of x plus 3 equals 32. So our first step is to rewrite 32 as a base 2 number. And that means we need to take 2, find some exponent, and end up with an answer of 32. So on your calculator, you try 2 to the exponent 3, 2 to the exponent of 4, 2 to the exponent of 5, and you will get 32. So what we now have is that 2 to the exponent of x plus 3 is equal to 2 to the exponent of 5. That's because this and this are equal. Now that we have the same base, we can equate the exponents. So we could drop these bases, and what we have left is x plus 3 equals 5. And our last step is to solve for x. So to solve for x, I have an x plus 3, so the opposite operation is to minus 3 from both sides. And I get that x is equal to 2. So this is the x value that'll make the original equation true. We could verify this answer. So if we want to verify, we take our equation 2 to the exponent of x plus 3. We sub in our x value. So remember we said that x is equal to 2. We sub that in, we get 2 to the 2 plus 3, which is equal to 2 to the 5, which is equal to 32, which is what the equation stated at the start. So again, this is our common base method, and examples like this will be ones that you will be asked to solve algebraically. The second method is when we have different bases and you'll be asked to solve using Desmos or solve graphically. All you do is take your two parts of the equation. So for example, this part here is y equals 10, 0.8 to the exponent x, and your second part here, y equals 5. Notice I have them here in Desmos as two different equations. So on my graph, here's the line y equals 5. On this graph, here's the line y equals 10 times 0.8 to the exponent x. Then looking for that point of intersection, which is right here, we now see what x value works. So we take the x component here, the 3.106, and that's our answer. X is equal to approximately 3.106. So that x value makes that equation true. And again, if we want to verify, all we do is we take our equation, so we're going to verify. So we have 10, 0.8 to the 3.106. That's our original equation on the left side. And all you want to do is type that into your calculator. And what you get is approximately 5.0003. So really close to 5. So again, here are some questions you should try before you complete your assignment. And if you have any questions, please contact me as soon as you can.